Hi all. In this video, we will be actually progressing our Saga series to create different topology in EKS Anywhere clusters, in which we will have a dedicated management cluster, which will actually then create, workload clusters, which will be managed via the dedicated management cluster. Now, essentially, in the previous video, I had spoken of standalone workload clusters, and in that sense, the management cluster, that will be created in this exercise is no different than a standalone workload cluster. So, in fact, I spoke about the fact that if I don't use a standalone workload cluster with any end user applications and I just leave it blank, what resides on that cluster is just the cluster API components and the EKS controller, right? So I can actually either reuse the previously created EKS Anywhere standalone cluster named C4 EKS, or in this case, we are recreating a new cluster, and we will not deploy any workloads on that. And then that particular cluster, the C4 EKS cluster being created now, will become the dedicated management cluster. So the only job that will have is to actually create new workload clusters and manage their life cycle. We can, however, on a need be basis, we can use the dedicated management cluster if the resources apply, or if the resources are available, to host some multi-cluster services like Cube apps or Argo CD toolkits, which are multi-cluster by design, right? So we can have that shared services running off the management cluster if the size is permitting, and then our workload clusters can use the end user applications actually, right? So this topology allows for different possibilities, and we'll not right now elaborate on those, but the point being, let's work through this topology. Also a quick recap that we have the EKS Anywhere admin machine created. Our Ubuntu OS template has been created for the cluster nodes. It has been customized to our requirement. We have the base template in place. So I think with that, we can start, working upon the topology here that we are describing of a dedicated management cluster, and then a couple of workload clusters, which will be actually feeding off that management cluster. So before we go ahead, let's also observe that similar to previous exercise, that the folder test EKS Anywhere right now is blank. There are no virtual machines. That means there are no cluster nodes which are actually, or clusters which are running in my setup. So we will start with a blank cluster, okay? And also this is a good point to reflect upon the cluster creation script as such. And if I just do a more on the script, I'll show what I mean here is there is a if-else statement that you can see here, right? And you can see that this one script, instead of running multiple commands and determining which command to be used while creating a standalone /management cluster versus using a different set of commands for creating the workload clusters, which will be managed through a separate cluster, this one simple script actually has the if-else statement. And it's a very simple script actually. If you know Bash, this is very easy. What I'm doing is basically, in the previous article, we had said that if the management cluster name equals to the workload cluster name, right? So essentially, after doing the variable replacement, we are using the command EKS Anywhere create cluster and the name of the YAML file, right, for the cluster specification. In this case, the bootstrap cluster got created and it communicated with vSphere asking for the resources in this particular YAML file, right? That's how the cluster got created to the bootstrap cluster. In this case, the cluster API pods, which in the previous case were there on the bootstrap cluster, to start with itself, we have this long-lived management cluster. So if the condition is that, the else condition, in which case the management cluster name is not equal to the workload cluster name, which will be the case now, right? We will create two clusters, namely C4, EKSA, say WK1 and WK2. The management cluster name for those two clusters will be C4 EKSA. Okay, so essentially there is a difference in terms of the management cluster name and the workload cluster name. Oh, very obvious. So the else statement will apply here. And you can see the command to create these kind of clusters which hang off the management cluster is to run EKS Anywhere create cluster, provide the cluster specification for the one that is being created, and then use a kubeconfig file of the management cluster, so that EKS CTL will understand that this YAML or this resource specification or requirement need not invoke a bootstrap cluster. It can actually run the the cluster API pods on the management cluster itself, right? Because essentially what you need to request the resources is cluster API. And right now, once the management cluster is created, the cluster API pods then reside on the management cluster itself. So there is no need for a bootstrap cluster while creating a workload cluster in this particular scenario or topology. So you can see that once I supply the kubeconfig file here, right, the directives actually will invoke a pass of this particular resource requirement for the workload cluster directly to the cluster API pods. In essence, there will be a new set of CRDs created in addition to the CRDs maintained for the management cluster itself, right? So cluster API has the CRDs for the resources which are running inside of the management cluster, the nodes and whatnot. Plus, when we create a workload cluster, a new set of CRDs is created, deeming that, or basically calling upon the need to actually host a separate cluster, within the management cluster's, cluster API framework. And every time you create a new workload cluster via this management cluster, the CRD list will keep appending itself. It'll actually determine the different sets of clusters which are managed through this management cluster. And we'll see this in action. But I just wanted you to see this script. And let's begin. I'm not going to talk through, the creation of the management cluster itself, because it is not similar, but exactly the same as what we did to create a standalone workload cluster. So this will take the first cluster creation, the management cluster, will take about 15 to 20 minutes. And we'll start the process, and I'll pause and then resume when it's completed, and we'll do some observations there. So I'm going to run the script to create the management cluster first. Okay, so create EKSA cluster.sh. Let's name this the same C4 EKSA. In this case, you can note that, I'm keeping the management and the workload cluster name same, like we did in the standalone cluster creation. So essentially that attests to the fact that, a standalone workload cluster and a management cluster is no different, right? So we start the process. I'll give it the IP address, the same IP address that I used previously, .11. And this is the API server running on my control plane. The version that I'm going to use is 1.22. Okay. So just a second. I think my old cluster file still exists. I'm just going to remove that one. Yeah. Okay. So let me rerun this script. Okay. So C4 EKSA and 172.24.165.11 and 1.22. So it will create a fresh cluster YAML file. There was a previous one, so EKS Anywhere detects that there is a config, and that's why the error. No worries, I think we'll go past that. The cluster starts getting created, the same procedure. Exactly the same. The template gets validated. And the resources, basically the configuration that is put into play from a YAML standpoint, it gets validated. All the inputs that have been given are also kind of, validated. Now, what follows is the bootstrap cluster creation. And, I don't need to talk too much on this, but bootstrap cluster will be created. Following which the cluster API pods on the bootstrap cluster will be created. The YAML templates, resource requirements will be translated into the resource request to vSphere. Then the target cluster C4 EKSA will be created. and then the Bootstrap cluster will actually pass on the CRDs to the to the workload cluster once it's created, and all the cluster API pods will actually resume on the workload cluster, and finally the cluster will be deemed as successful, right? So let's just wait on for this, and we'll come back. So we can see that about after 10 minutes or the Bootstrap cluster activities are completed. I mean, not completed in the fact that the new workload cluster is being created. Let's observe this cluster in the vSphere console. So I can see that the 3 etcd nodes for the management cluster have come up. The 4th, which is the control plane, is coming up. We'll wait for a few more minutes till this set of routines is completed, and then I'll share some more observations. So we can see that the cluster has been created, our management cluster, which in the previous exercise I was calling C4 EKSA as the standalone cluster. In this case, I'm just changing the terminology here. So this management cluster has been created. Again, just to kind of make sure that we are able to access this cluster, let's just set the kubeconfig context, kubectl context, and I'm going to run my switch script here. So cluster ops, switch script, and C4 EKSA. Okay, so with that, I should be able to get the node information, get nodes. So you can see that the 4 nodes are being displayed here. The same thing should be available in my vSphere console. So you can see the 7 nodes. The etcd, as I mentioned in the last activity, is not a part of the kubelet, right? So no kubelets are there on these, so I don't see that via the kubectl. Now, point is that I'm not going to deploy any applications on this, like what we did a hello world application on that previous standalone cluster. In this case, we will reserve this cluster for doing what it is intended for, like a management cluster. But before we proceed, let's also see the CRDs on the cluster. So we can see that the machine configurations of this management cluster itself are presented in the form of CRDs, and they are basically in the EKS system, basically in the namespace of EKS system. So let's describe one of the CRDs to see if I have my machine configurations. I'm just going to repeat this command and take the value here. Let's take the machine templates. Okay. And kubectl get, right? And we can see that the C4 EKSA, which is this management cluster itself, the CRD for the control plane, the etcd template, and the worker nodes, they are all there, which means that I can change, like I described previously, I can change the size of the management cluster, but by changing the CRD, by supplying a YAML template of a changed configuration, and the EKSA controller on this management cluster will be running and watching for those resource request changes. And then like in the previous exercise, we can adjust and scale the management cluster itself, right? So you can see this is running in the namespace EKS system, and these are the CRDs to be worried about or to be concerned with, right? Plus on top of that, we can also see that the controller is running in terms of EKSA controller, EKSA system. So the EKSA controller is going to be watching for any resource requests, which means that for this management cluster, in terms of size and configuration, and then altering the CRDs, which we just saw, or creation of the new cluster, a workload cluster that will be managed via this particular management cluster. Okay, so we'll see that also happening. For now, what we have seen is the CRD template for those 3 type of nodes. Let's also see if my individual nodes are also reflected as, let me get this. Okay, so I'm going to take the vSphere VMs CRD, okay, and just get information about that particular CRD running in the namespace EKS system. You can see that all my 7 nodes are also reflected as Kubernetes resources running inside or posted as CRDs inside EKS system, right? So any changes, they'll be coordinated through the template and then individually, applied to these node configurations, right, for each of the VMs. So the whole tracking system is set from a management standpoint. Now, what we will do is, just to make sure that you're on the right track. Now our next goal is, we have the management. Okay, let me also show you the cluster API pods just for a reference. We've seen that in the previous exercise. You can see that the cluster API pods are also running on this management cluster, right? Okay, so everything is good. Now what we will do, we will create a workload cluster, okay, a new workload cluster, but it will not be a standalone workload cluster. It will be a workload cluster in which the management cluster will be C4 EKSA. So the script is the same and the process is also the same. The routines will be a little different and you will see that happening. So let's create a EKSA cluster. Let's run the script. If you recall, the if-else statement now in this case will detect that the cluster name, which we will keep it as, let's say, C4 EKSA, let's say W1 hyphen W01, let's say. Okay. So this is going to be the workload cluster name. I'm going to keep the management cluster name as C4 EKSA. That is what the management cluster that we will be referencing. The if-else statement, when the script gets executed, the if-else statement will determine that, okay, the management cluster name and the workload cluster name are different. So it will use the kubeconfig of the management cluster to directly call upon the cluster API and the EKSA controller, to add the CRDs passed via the YAML template that will be auto-generated by the script for the target cluster to be created, which is C4 EKSA W01. Let's see that in action. The IP address for this particular cluster, I'm going to keep it as .12. This is the API server IP address that will be running on the control plane of the new workload cluster. And the version of Kubernetes, I'm going to keep it as 1.22. And a similar routine will follow. The validation will happen, okay, of the YAML template, which has been created already after the script got executed, specific to the W01 cluster. And once that happens, I'll show you some interesting, observations here, that it did not create any bootstrap cluster. You can see that, right? I mean, while the management cluster got created, or even in the case of the standalone workload cluster in the previous activity, there was a bootstrap cluster first created. In this case, there is no need for a bootstrap cluster because EKS Anywhere, or the EKS Anywhere package decides that because the management cluster is present and it is not the same target cluster, I will be using the kubeconfig and pass on the YAML directly to the target management cluster, and the cluster API and the EKSA controller running on that management cluster, that is C4 EKSA, will take care of talking to vSphere, because essentially what we need to do is translate the YAML for this cluster into resource requirement or request to vSphere, right? So who will do that? In this case, the bootstrap cluster will not do it. We have a long-lived management cluster which runs these cluster API pods. So this YAML, which is generated, I can show it to you in a different terminal, but there's a YAML template generated for this from the base YAML that is now being passed on by the C4 EKSA cluster to vSphere and to create this new workload cluster. This process will be shorter in terms of the time required to create the workload cluster, as opposed to creating a standalone workload cluster. Because you see, there are a few extra steps that happen in creation of a standalone workload cluster or a management cluster. Essentially, the bootstrap cluster creation and the cluster API coordination and movement of the cluster API resources and all that. All that is not does not exist in this set of routines. It's just directly the creation of the workload cluster, and we can see it in my vSphere console as well. You can see now a few more machines have started popping up. Where is it? Okay. Yeah, you can see these ones, the W01. So 4 machines. So you can see the C4 EKSA. This is the management cluster nodes. Okay, these are the worker nodes of the management cluster, the control plane node, the etcd node, and the other control plane. These 1, 2, 3, 4 as of now are the 3 etcd nodes of the new workload cluster. Okay, W01, W01, and this is the control plane being created for the new workload cluster. We will see how it progresses. Okay. And let's see, anything else has been created? Not yet, only 4 machines. Totally, there will be again 7 machines, 3 etcd, 2 control, and 2 worker. So let's see, okay. Let the process get completed. I'll show you a little more observations. So I can see a few more machines have been added. So the total count is 1, 2, 3, 4, 5, 6, 7. So the cluster nodes as such, they've all come up actually for W01. And this is quicker than, a standalone workload cluster / management cluster. This was a fairly quicker operation actually. Let's go back to the, so now what is happening is basically, you can see here installing, and then now in a regular, as a regular step, the CNI is being installed, the Cilium CNI, and the default storage class, which is based on vSphere CSI, is being installed, and whatever is required other than the above is also done. Now the cluster is fully created, okay, and it has also written the cluster config file. So now we should have basically a new directory. See, I said that the management or the standalone cluster during creation process, every cluster creation process creates a new subdirectory under the home, named by the cluster itself. So if we go to C4 EKSA, for example, which is the management cluster, we can see that, the kube config of the management cluster, the YAML of the management cluster, which was used to actually build the cluster itself, the SSH keys and whatnot, right? Now, we should also have now one more directory created, which will be called as C4 EKSA W01. So you can see this, right? And inside of this, basically, you will have the W01's kube config, the YAML, which is used to create the cluster, and then the SSH keys. So now we can have a nicely organized, set of subdirectories, each basically named with the cluster name itself, actually, right? And then, like always, we can commit these files to GitLab, invoke a GitOps routine, or we can manually kind of edit these files and apply the changes. Now, when we edit this file and apply the change, we have to note that in the case of these kind of clusters which have or are managed via a dedicated management cluster, you will have to provide an extra argument to actually pass the kube config file of the management cluster, because these changes, they will need to be provided or handed over to the cluster API running on the management cluster. So you don't, if it's a management cluster or a standalone workload cluster, you don't specify the kube config as such, right? Because the cluster's context is already pointing towards the management cluster. In this case, we will have to necessarily provide the kube config such that the changes in the YAML are understood as resource requirement changes for in a CRD sense, and those machine configurations that will be changed inside this YAML are placed as a resource request actually, and then the bootstrap, so not the bootstrap, sorry about that. The cluster API components running on the management cluster will talk to vSphere, do the necessary, and we'll see that as well, right? In a similar fashion, let's also, okay, so before we move ahead, let me switch the context now to this cluster. So if I run the kubectl now, okay, get nodes, you can see that as of now, my kubectl context is pointing towards the previous or the management cluster itself, right? So I'm seeing all information from the management cluster. We have a new cluster. So let's, in order to observe the W01 cluster, I will just rerun the script saying source, EKS Anywhere, cluster ops, and switch cluster. Okay, and just supply the C4 EKSA W01. And let's see if I can get the node information, if my kubectl can talk to the cluster. Note that this is not a, the management cluster has no role to play here in these kubectl operations. It's not a proxy of any sorts. It's a direct call, API call between my kubectl running here on the machine and the workload cluster. So it's not a proxy configuration where, every API call to the workload cluster goes through the management cluster and whatnot, right? Nothing like that. So other than the fact that, if I want to do some changes on the workload cluster in terms of node configurations and all that, then I have to actually point my kubectl to the management cluster. But right now I'm directly fetching the information from, the workload cluster itself, actually, C4 EKSA W01. Okay, so I can see the cluster nodes. And obviously now I can start, just kind of, deploying applications. This is as simple as it gets actually. Okay. In the context of doing so, we will not deploy any application as of now. First, we will create one more cluster. Or should I? Okay. Let's also see one more fact. Sorry about that back and forth here. Some interesting callouts. kubectl get pods -a. This is a very important observation that one needs to do. There is no cap or cluster API pods running on the workload cluster. This is where I want you to be. This is the spot where we understand the essential difference between the makeup of a workload cluster and a management cluster / standalone workload cluster. You can see that in this case, there is no cap V, there is no EKSA controller pod running, nothing like that actually. And I will not have any of those CRDs as well. Kubectl get CRD -a. Okay, so you can see that in the management cluster or the standalone workload cluster, there were a lot of CRDs that you could see, right? Because all of that pertain to the resource configuration of different clusters, including the management cluster itself. And now you can see here, I don't have any cluster API pods in the workload cluster. I don't have any machine configurations and all that because the workload cluster will not participate in any deciding for itself. Okay, so there is no need for keeping those CRDs here. All of that CRD should be stored in the management cluster, right? We will observe that as well now. So I will switch back to my management cluster. I'm assuming you guys are technical, so you don't mind these kind of demonstrations. So C4 EKSA. Okay, so I'm switching back to my management cluster, and let's just verify I am on the management cluster. Yes. And now if I actually, let's say, call upon the CRD listing, shall I do a history, or let's grab kubectl get CRD -a, grep vSphere. So let's define this particular, or let's see now what this particular CRD has to say. Recall that when there was no workload cluster which was created, it was just the management cluster. the CRDs that were there were for the management cluster itself, right? So I will say this and minus n EKSA system. Okay. So let's see now in this case, you can see that previously we had only the management cluster's own CRDs listed here. And I'm using this word CRD again and again, but you should understand these are the configurations, resource configurations and the machine configurations for these particular set of nodes or type of nodes in the cluster, right? So this is for C4 EKSA, which is the management cluster itself. And because now we created a workload cluster, which was done via the management cluster, you can see that in the EKSA system namespace of the management cluster, a new set of CRDs has been created. Now, this should help you understand what has happened essentially, right? When we use the script to create the cluster, the EKS Anywhere cluster create command embedded in that script, use the kube config file of the management cluster, and then place these resource requests / configurations inside of the namespace EKSA system. EKSA controller watched for these requirements, communicated those to cluster API spoke to vSphere added those particular new machines, and then the loop closes via whatever routines that we saw actually, right? So this is where it gets interesting. Now, you also understood the essential difference between what type of or what is the makeup of a workload cluster, which is managed via this management cluster, and then the management cluster / standalone workload cluster itself, right? So essentially, it does not bear any cluster API pods. It does not run any EKSA controller system and all that actually, right? Plus, it does not have any CRDs. The workload cluster does not have any CRDs. Now, let's do one thing. We will create another cluster, okay? And in doing so, we will run the same script actually. Okay, so source, create EKSA cluster.sh. In this case, we will name our cluster as C4 EKSA, let's say W02. Okay, so this is the second workload cluster that we are creating, and you can just keep repeating this script, to create more and more clusters. And we will observe a couple of things. Management cluster name is going to be the same C4 EKSA, which now resembles a central point of management, and hanging off that management cluster are these workload clusters, right? So the tentacle effect comes in play. You manage all these clusters from a resource, scaling, upgrade, and whatnot through the management cluster, right? So let's just push this thing, 172.24.165.13, let's say. So my management cluster is .11, the API endpoint. The workload cluster W01 is .12, and this new workload cluster which will be created, its API endpoint will be .13. The version, I can keep it different, 1.21 also, or let's keep consistent 1.22. Okay, so you can see that the script has started to execute. Okay, now it's interesting to show you. Let me see if I have a duplicate session already opened up. Okay, so ls -al grep C4 EKSA. Okay, so you can see that the directory is already there, which is created by EKS Anywhere. Okay, the directory is also created for W01 cluster, but essentially you can see these YAMLs, right? So this is what the script does. It creates this YAML with the variables and all that that we just supplied as inputs. And you can see this YAML which was created, and this is the new YAML which is created as a part of the script being executed for the new cluster, right? Same process, the workload cluster is being created directly, no bootstrap cluster whatsoever. Plus now the YAML, which is this one, right? Let's look at the YAML here, more, and this is the YAML. So essentially, I've explained this now n number of times. I think you should be able to figure it out. This is the cluster configuration, right? In terms of the how many, count of etcd nodes, count of worker nodes, count of control plane nodes, the API endpoint, the Kubernetes version, and all that, plus the individual machine configurations for the etcd nodes, the worker nodes. So you can see that number of CPUs, all that is there, right? So point is that you understand this is the YAML, and all of these are CRDs, custom resources, right? And the kind of CRD is vSphere machine configuration for all these control plane, worker, and etcd, right? So these are, again, when you deploy a CRD, it now goes and sits into the namespace of EKSA system on the management cluster. Once it detects this is a requirement coming in with this name and metadata and all that, it will start creating, the resource request to vSphere, right, via the cluster API pods, right? I think I'm repeating myself again and again, but point is to, assert this and make it firm that this is how the process works. Now you can see that the W02 pods or nodes, not pods, have also started popping up in the vSphere console, which means this action that we are seeing here, the create new workload cluster, no bootstrap cluster, the workload cluster is being invoked on the vSphere environment, right? So 1, 2, 3, 4 have been created. We'll give it a couple of minutes. Again, as I said, that the routine will be shorter than creating a standalone or a management workload cluster. So let's just give it a few minutes here. So we can now observe that our W02, that is cluster number 2, is also created. And no surprises there for guessing. There's no bootstrap cluster. It was just a direct workload cluster creation. So everything is done. What we will do is now just see the cluster node. So I'll change the kubectl context. Right now I should be on the management cluster, if I'm not mistaken. Okay, yeah, so my kubectl is pointing towards the management cluster here. We will use the switch cluster script. So source EKS Anywhere, cluster ops, switch cluster, C4 EKSA W02. Okay, so kubectl get nodes. So we can see that I get my nodes for the W02 cluster. The vSphere should also have all this. So it looks like a lot of machines now popped up, right? So I have my EKSA, which is the management cluster, the W01, the workload cluster, and then the W02, the workload cluster number 2, right? So essentially, if you now want to work with different clusters, obviously, this is a EKS Anywhere admin machine, and then I can switch my kubectl context like regular business, right? And I can deploy applications, I can deploy everything and anything. But the premise in which the management cluster will operate, I can still deploy applications on the management cluster and not call it management cluster. But for the sake and context of having a topology which is true to the intent, we will have the management cluster without any applications, and then we can switch the cluster and deploy our end user applications on this. The point now will be, how do I scale these particular clusters, right? The workload clusters here. The intent is very simple here, right? I mean, we still actually, let's switch back to the management cluster here, EKSA, yeah. And then if I have to switch or scale workload cluster number 1, okay, that is C4 EKSA W01, I go into that particular, or let's say I say EKS, we can either use the EKSCTL upgrade command. We can use this EKSCTL Anywhere upgrade. Okay, so this is a one way of doing it, as I explained in my previous article and blog, where we were upgrading or changing the resource configuration for the management cluster. Here, or then alternatively, we use the kubectl, right? kubectl command to actually edit the cluster configuration. So now understand that my kubectl is set to the management cluster, right? So I'm going to say kubectl get cluster. How many clusters should I be seeing? It will not be one, it should be 3 clusters. Now, like I said, the get cluster, the cluster is a custom resource. The kind of resource is cluster. And I'm actually polling the management cluster. It is actually retrieving that information and giving me the CRD defined, these 3 clusters now. Okay. No surprises there. How the interaction works, I think you should be comfortable by now, but this is the point that I'm trying to make here, that we have now 3 clusters. I can edit or do a kubectl on any of these clusters. Because my kubectl is now pointing towards the management cluster, I can do a, like I said, edit any of the clusters, and the same process will be invoked. Basically, the change will be communicated through the EKS controller, EKSA controller, cluster API to vSphere, and cluster API runs on the management cluster, no bootstrap there. So let's say kubectl edit cluster, C4 EKSA W01. Okay, and I'm gonna change again like the last time. Okay, I think I should not use VI. I will use my favorite one here, Nano. Okay, and kubectl edit cluster C4 EKSA W0. Oh, okay, W01, and sorry. Am I doing it again? Cube editor. I have missed equal to, yeah. So let's edit this, and I want to increase the worker nodes in my W01 to 3. Okay. Note that I'm doing this through the kubectl, and kubectl is pointing to my management cluster. So the API call will go to the API server of the management cluster. While I'm doing this manually, like I said previously, this all, since it's standard kubectl, it's an API call. It can be done through a GitOps process, or it could be done through a pipeline process of sorts, where this particular YAML file, if placed in GitLab or GitHub or anywhere else, right, a pipeline can trigger this change to edit the YAML and pass this YAML through the API calls. And let's make this 3, and let's save it, right? And as soon as it is saved, we will see that clusters. Okay, kubectl cluster. The count of cluster is the same, but now I have to see if the node configuration for the W01 cluster is increasing or not. Now, there are many ways I can directly query the management cluster, but essentially what will be the moment of truth is if I just switch my kubectl, sorry, okay, source EKS Anywhere / cluster ops, switch cluster. C4 EKSA W01, and then I will start polling the cluster API, the cluster's API endpoint directly, and say kubectl get launch. So we can see this is what we were looking for. You can see that the new node, the 3rd worker node, is also being inserted into the cluster setup. So this prominently highlights the fact that I have not made the change of settings or the cluster creation YAML and all that on the workload cluster directly, because this is a managed workload cluster. So I just directed and instructed my management cluster saying that, recall I was pointing the kubectl to the management cluster. So I just edited the YAML, which is the CRD, on the management cluster, pointing for this or referencing this W01 cluster. I changed the count of the worker nodes there and got back to the W01 cluster, and I'm seeing that the third node actually for the worker nodes is coming up actually. So we'll wait for this node to come up and then we'll summarize. So let's quickly observe if the nodes are ready. So now we can see that all the 3 nodes for my W01 cluster are ready. This is the latest one that we actually created by scaling the W01 cluster. Likewise, I mean, I don't want to continue any further to repeat the same act, but likewise, you can actually scale your W02 cluster. Likewise, you can scale your management cluster by just switching over to C4 EKSA, which is the management cluster. Here, kubectl, get clusters, and just use the kubectl edit cluster command from the EKS Anywhere administrative machine, or if you have the kubeconfig or the OIDC enabled, SSO enabled on the management cluster, you can log in from a different terminal, or like I said, from a third-party system or a pipeline or whatnot, and actually punch in these resource changes so as to change the cluster configuration for management, workload clusters, and whatnot. So this brings us to the before closing out, if you have to edit, so we saw an example where we edited the worker count actually for the clusters, right? If you have to edit the machine configurations in terms of CPU and memory and whatnot, you do the same thing. Instead of kubectl get clusters, we can get kubectl the CRD, which hosts the the machine configuration templates. Okay, and let's say this one, machine templates. Okay, clear, and kubectl get machine templates -n EKSA system. So note that you can see here also, right now you have the control plane template, the etcd template, and the worker node template for my management cluster. Similarly for W01 cluster and W02 cluster. Now, if you edit this particular CRD, which is the machine template, you can actually then, so you saw the YAML how it was constructed, right? So there is a resource block of the kind cluster, and then there are vSphere machine configurations actually, right? So you can go ahead and edit, for example, let's say cube editor equal to nano, and kubectl edit. Let's take this particular CRD type and the name. Let's say if I want to edit the worker 02, okay, -n EKSA system. So now you can see here this template. Now you can specify the memory, which we can change from 819 to 16384, 16 GB, or the number of vCPUs to be changed from 2 to 4. And if I edit this template and save it, right now I'm not going to do it. What it will do is basically, invoke a similar process, and the resource change will trigger the EKSA controller to detect it. Cluster API goes back to vSphere. The worker nodes will be recreated because this is not an additional node. You're changing the resource configuration. So the existing 2 nodes in this, or if I edit this particular worker node configuration, the existing 3 nodes running on this particular cluster, they are all of the 2 vCPU and 8 GB RAM. They will be upgraded, in a phased rollout manner. And if there are any live containers running on it, Kubernetes will take care of all that to move the containers and all that. So I think you get the point. So new nodes will be created and the existing nodes will be replaced with the new nodes actually, because it's a new resource configuration. At the end of that, all the reconciliation that has to happen will happen in the context of the management clusters namespace and these CRDs actually. So with that, I would suggest we close this video. It has been a pretty long conversation. Again, it's not for the the layman to understand this video. I intentfully put this video to cover what's under the hood, and some things which are not so obvious from reading the documentation otherwise, right? Otherwise, like I said, creating the cluster is just executing one script actually, right? So thanks a lot. Cheers.